Yeah, comes on everyone. Let's start off. Great. So last thing that we did, we started with thermal expansion, and yeah, this is the only formula we are playing around with. L final is equal to L initial into 1 plus alpha delta T. This is when alpha delta T is very small, which is actually the case. In most of the cases, it is always small. In some rare exceptions, right? Like the hypothetical materials, when alpha delta T is comparable, you'll get L initial into E power alpha delta T. So don't use that until unless you're sure alpha delta T is comparable to 1. Mostly at a mains or bits, they never touch that thing. So like this was the last question that we did. When you clearly see here, alpha delta T was 1. So only when numbers are given, use that, or else don't do this. Always assume it is small. Right? So yeah, let's continue with that. So we have two rods here, L1, alpha 1, L2, alpha 2. Right? So composite rod. Find alpha equivalent. We have done something like this, Y equivalent in elasticity. Let's get this. Others to keep your cams on. Again, in these kind of questions, what are the catch? You have to replace this whole thing with one single rod. Whose length will be L1 plus L2 and alpha equivalent. So the change in length delta L must be equal to change in length delta L1 plus delta L2. That is the idea there. So in both the cases, the total change in length must be same. So when you increase the temperature by delta T, whatever is the change in length of the two rods must be equal to the length of this rod. So this is L1 plus L2 alpha equivalent to delta T. L1 alpha 1 delta T plus L2 alpha 2 delta T. Delta T cancels off. We get alpha equivalent will be L1 alpha 1 plus L2 alpha 2 by L1 plus L2. Check. Easy. So these equivalent problems are important. Like I said, mains or bits mein na, they do, and CET mein they do ask a lot. Find Y equivalent, alpha equivalent, and बाद में देखते resistance में they'll say find R equivalent. We got a rod here. X is equal to 0, X is equal to 12, initial temperature is 100 degrees. Case 1, the quotient of linear expansion is alpha naught into T. It is changing the temperature. Means the higher the temperature, more the alpha is increasing. So alpha is not constant. So your coefficient of linear expansion is increasing with temperature. T is temperature in Kelvin. In case 2, same rod, but this time alpha is changing with position. Meaning different positions of the rod have different alpha. You're getting, in case 1, alpha is changing with temperature. When it is 100, you have different alpha. When you have 150, you have a different alpha, and so on. But the second case, it is changing with position. So in both the cases, find the change in length when temperature becomes 200 degrees. Nu by D. What is Nu and D? No idea, Srihari, what you're saying. Solve. It's okay. Get this thing. Ishwan, nothing is mentioned now. You should take always alpha is small. Exponential nahi aayega. So basically, when you use that formula, dl is equal to L alpha dt, we are going to use this L is constant. That L is so small, we ignore that actually. So basically, we're using that formula, delta L is equal to L alpha delta t. Like I said, nothing is mentioned. Always take alpha is small. Only when numbers are given, then you take that alpha delta exponential thing. So that is one thing, that I actually fear. Because I teach you that exception thing, people start using it everywhere. Unfortunately, you don't use that until unless numbers are given. Let's see the first one. Case 1, so if you take your change in length, alpha is equal to alpha naught t. So dl is equal to L alpha naught t, that is your L alpha dt. So when you apply this formula, right, what you're doing is actually you're treating this to be constant for small alpha. So that L is not actually, technically it is a variable, but we are ignoring it. This is constant for small alpha. So dl L alpha will be alpha naught t dt. Now till here it is all great. This is the mistake people do. Here temperature is given in Celsius, 100 and 200 degrees, but here it is written temperature is in Kelvin. So when you take the limits, you have to be careful. The limits has to be 373 to 473. Don't put limits 100 to 200. So here this will be your delta L, which is L alpha naught 473 minus 373 square by 2. And that's a very classic mistake. There was one question like this in JEE mains like 4-5 years back. You'll get answer ln T final by T initial. ऐसा कुछ answer आएगा. And they gave something like temperature changes from 100 to 200 degrees. Everyone substituted 100 and 200, they got ln 2. And the best part, even JEE people took it as ln 2. Even they did that mistake. The answer was actually root 473 by 373. They gave bonus. So temperature is in Kelvin, so be careful with that. So in the formula PV is equal to nRT, T must be in Kelvin. So for case 2, now X is alpha is changing everywhere. So what we do at a distance X, we take a very thin piece. So this thin piece dx, in this dx we have a small elongation de. So de is a change in length in dx. We have done this in elasticity if you remember, for variable tensions. So we get de, the length of the rod dx, alpha naught x, that is your alpha, into delta t. So here remember, the change in temperature is same for everyone. So the elongation will be alpha naught delta t integral x dx. from 0 to 1. Now delta T will be 100. Whether you take in Kelvin or Celsius, the difference is always that, and L square by 2. This is the elongation in the second case. Please have a look at this. So in the first case, you're integrating with respect to temperature. In the second case, you're integrating with respect to x. So when you integrate with x, change in temperature is constant. So basically, every point on the rod will have same temperature difference. All clear with this? So this is one thing, be careful. Since alpha is small, you have to take that length to be constant. We are not going to take the exponential thing. They give you some numbers, then it's a different thing. All clear with this? Next thing. Now, these are important questions. These are questions connected to elasticity, which we couldn't do there. Now we are going to do them. And this is important theoretically, so listen carefully. So we got a rod on a smooth surface. Young's modulus, area of cross section, length, alpha. Find the stress and strain when temperature changes by delta T. OPK is Romberg stress and strain. Strain delta L by L, and stress is Young's modulus into strain. Others, you need to keep your cams on, or else I'll start removing you from the class. How do we do this? Now listen, this is an easy one, but you have to be careful here. Let's make something clear here. First of all, the delta L in elasticity and the delta L in thermal expansion are not same. These two are actually two different delta L's. So understand one thing. When you're increasing the temperature, why is the temperature changing in the first place? Why is the length of the rod changing in the first place? Now, if you remember the whole story when we started this chapter, we said the length was L when the temperature was T. Right? And when you increase the temperature, the length became L plus dl for the new temperature, T plus dt. So this L plus dl is your new natural length. So the reason why the rod expanded is because the molecules are vibrating more rapidly. They needed more space, so they want to be more comfortable without hitting each other, right? So that is the reason the length has increased. Right now, in elasticity, when you took that longitudinal strain, delta L by L, in this, the delta L was the change in length from natural length. Both the deltas are not same, right? So let me give an analogy. Think of like this. Let's say if I catch your cheeks and I pull them, does it hurt? It hurts. But imagine you eat a lot of food and you become fat and cheeks become big. Does it hurt? Now, in both the cases, the cheeks changed by the same size, same amount. But why in the second case is not hurting you? Because that is your new natural size. Are you getting it? So previously, when I started pulling them, I was forcing you to stretch from your natural length. But when you became fat on your own, your natural volume is that new size. So now when I ask you in this case, find the longitudinal strain. So this is what you do. So for here, the delta L will be L final minus your natural length. So it is a comparison with respect to your natural length. What is the final length of the rod? L plus L into 1 plus alpha delta t. What is the natural length of the rod? L into 1 plus alpha delta t. So what is the change in length? 0. So if you ask the rod, how are you feeling? Rod will say, okay, I'm supposed to be L into 1 plus alpha delta t. I am L into 1 plus alpha delta t. Therefore, strain is 0. I hope you're getting the difference. That delta L and this delta L are not the same. Now, if the strain is 0, then we know stress is nothing but. I'll give you one more problem on this, so that will make things more clear. That will be y into strain. So stress is also 0. So if you actually think about it, the reason you expanded in the first place is because you don't want to have any stress in the material. Is this making sense? What both the delta L's mean? Let me give you one more analogy, okay? Think of like this. Let's say your salary is 1 lakh. Okay? Your salary is 1 lakh per month. And I told you from next month onwards, I'm increasing your salary to 1 lakh 20,000. Okay? So I said I'll increase your salary to 1 lakh 20,000. But when the next month comes, I tell you, Arey yaar, the management didn't agree with the salary and everything. So sorry, baad mein dekhte hain, but for now your salary is only 1 lakh. Does it pinch you? Does it feel bad? Or you're okay with this? Now tell me one thing. Did you ever get 1 lakh 20,000 salary before? You never got it, right? अभी तक आपका salary 1 lakh ही था. But then, so if I give you the same 1 lakh, why did it start hurting you? That is because the moment I said your new salary is 1 lakh 20,000, this has become your new natural state. That is your new salary amount, which is fixed in your brain, isn't it? Now, when I gave you 1 lakh, you started feeling you lost 20,000. Are you getting the point? Getting the difference? But if I say I'll give you 1 lakh 20, and if I give you 1 lakh 20, is there any surprise there? You're fine, right? Matlab, that's what I promised you, and that's what I'm giving you, so you're fine. But imagine if I give you more, you'll become actually a little more happy, right? Oh, that was getting more than you told me. But if I give you the same 1 lakh, now you're not happy anymore. Even though that was the salary till last month, just because I said one word that next month onwards I'll increase by 20,000, you started believing that's your new salary. Kind of making sense. So something similar happens here. So for the rod at temperature T, the length was L. When you increase the temperature, the rod starts believing, okay, L plus DL is my new length. That is how it's supposed to be. Clear with that? So when you ask what is the change in length from elasticity perspective, elasticity will say, okay, your final length was L into 1 plus alpha delta T, and you are supposed to be 1 plus alpha delta T. So delta L is 0. Are you clear with this? Making sense? So I'll give you one more question on this. I think that will make things even more clear. But roughly, did you get the idea there? So be careful with that. Delta L in elasticity and delta L in thermal this thing are not same. Thermal expansion. Same question. Let me frame it this way. We got a rod placed between two walls. Rough wall, friction mu, mass m, length L, area, Young's modulus, alpha. Gravity is present. So here the rod is loosely fitted between the walls. Find the change in temperature if the rod does not slide between the walls. So if you increase the temperature sufficiently, rod will get stuck between the walls. Now both are connected. Give it a try. Try. I'll give another 30, 40 seconds. Take a minute. Let's see. So now, if you look at this rod ka scenario, now the new temperature, at temperature T plus delta T, the natural length was L into 1 plus alpha delta T. So the rod will think I'm supposed to be this much. But due to walls, you couldn't expand. So this is classic, that example I gave you. I said I'll make your salary 1.2 and I'm giving you 1. Due to walls, the length remains L. The rod will not think, okay, I'm initially L, now I'm L. Rod will think I'm supposed to be L into 1 plus alpha delta T. But for some reason, I couldn't expand. Therefore, rod will feel it got compressed. So the change in length for strain, so I'll just put the word strain here because I know the delta L can be confusing, will be your L final minus your L natural. So your L final was L and your L natural is L into 1 plus alpha delta T. So you end up with minus L alpha delta T. Minus indicates compression. Now when you apply the formula here, the Young's modulus, tension is equal to YA by L natural into delta L. The formula becomes YA. You can remove the minus sign. It just means compression. L alpha delta T into L into 1 plus alpha delta T. But alpha delta T is very, very small compared to 1. So we can neglect this. And this guy approximately becomes YA alpha delta T. I'll do one thing. I'll take it as N because we are already using T for this. What is this N? This N is the tension in the rod. So the rod is being pushed by N. So because the rod is trying to expand, the walls are pushing it, and this is F and this is mg. So the tension in the rod is N. So we get 2F is equal to mg. F is equal to mg by 2, but friction should be less than equal to mu n. So we get mg by 2 must be less than equal to mu n, and n is nothing but Ya alpha delta T. So we get the change in temperature must be mg by 2 mu Ya alpha. So as long as you have temperatures greater than this, the rod will not slide. Right, Arya. Are you clear with this? I hope now you are able to see the relation between this and the previous one. So I kept both of them together. So in the previous case, there is no one to stop you. So you expanded and you became the natural length. So there was no problem. There was no strain. But in the second case, you didn't let it expand. So we have a problem.
Sir,
Yeah.
sir, they should also mention ki like minimum, right?
ठीक है ना, we got it. I found all the values you want. So great. I said find delta t na. So inequality is there. What is the problem?
Okay, sir.
You found a minimum. All clear with this? And this thing, right, can really be a lot of stress. Huh? Did you ever, when you go on a flyover, did you ever hear this thing? You'll hear the tuck, 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 tuck sound. And when you actually look down on the road, you'll observe the flyover actually has sections. and there's a thin gap between the sections. So that is because during summer, when the roads become really hot, they leave very tiny space between them for them to expand. So if you don't leave that space, the sections will push each other and you get a lot of internal stress. So this thing even can go wrong with the railway tracks, huh? So even railway tracks, right, during summer when they get really hot, they can become sometimes like this. This is called buckling. So previously they used to use thin gaps, but nowadays, right, they actually use reinforce this thing. Now it doesn't happen much, but it can happen like this. India mein to, we know the temperatures are going to be anyway high, so we are taken care of. Especially Europe mein it happens. Europe mein they build a track. Normally the temperatures are 10-15 degrees. Unfortunately, in one time they'll get a temperature of 35. They think that is summer, right? I mean, for us 35 is like theek hai. People just survive. 35 to in Europe people actually start getting sunstrokes and everything. So yeah, things get really messed up. But same thing goes, right? When the temperature drops to 10 degrees, we start freezing. For them, 10 degrees is like they'll wear shorts and roam around. So they are adapted to cold. We are adapted to heat. It works. Now let's see one more like this. So we have a hollow shell. It is filled with water at 0 degrees. B is the bulk modulus of ice. Density of water is 1 gram per cc. Density of ice is 0.9 gram per cc. Now, find the pressure on the shell. You know, anomalous expansion. When the water becomes ice, it tries to expand. Find the pressure on the shell when water freezes to ice at 0 degrees. Assume the shell does not expand in this phenomena. Now, India, you don't notice this, but in cold countries, right, this is really a big problem. Right? You have water in the pipelines. It's called buckling, right? Buckling. Bucking nahi hai, to. So yeah, so in cold countries, what happens? If you see the difference, right, in hot tropical countries like India and all, if you look at our houses, we have the plumbing outside the house. In cold countries now, what they do, they have the walls, they have a false, walls which are insulated, and they have the pipes inside of this. Because if they keep the piping outside the house during winter nighttime, when the temperature drops below 0 degrees, water will freeze. You go to the bathroom and flush, and water doesn't come because everything is stuck. And that is the reason whenever you have a fire in this, cold countries, if you see the whole building goes on fire. India, mein agar when a building has fire, rarely it catches fire. Other than the furniture which burns inside, nothing happens to the building actually because it's full of made of cement and bricks. That is because they have a lot of insulation material which is easily, catches fire. कभी देखा इंडिया में there is a fire and the whole building is on this thing? It never happens. Maybe एक floor में थोड़ा smoke आ रहा है and like things are fine. But if you see in cold countries, right, literally the whole building is on fire. So these pipes, if you don't design them properly, this is what can happen. Their copper pipes will literally tear apart. You can actually do this. You can buy a Coke tin, put it in the freezer, not in the normal thing. Put it in the freezer. Just leave it there for 4 hours and see what happens. The whole thing will get distorted. Matlab, the can which is like this, after 3-4 hours, the whole thing inside becomes solid and there is no space. This thing will become some, weird shape it will form. Matlab, the whole thing will just, it will not explode, but it will just expand. If you put a glass bottle, it will crack. So one day I brought a Sprite cut in and I wanted to cool it faster. I kept it in the freeze and forgot. Evening when I opened it, it was in some weird, shape. Yeah, luckily it works out. And that is the reason you should never put paneer or tofu in the freezer. Because these things are made of a lot of, water inside. There's a lot of water content. So when you put in the freezer, the water will freeze and that will expand and the paneer will break from inside. So even if you try to put it in hot water, it will become into pieces. You won't get that solid blocks. Same way, you should, if you got a, frostbite or something and if your hand freezes, the blood in the arteries and vessels, right, will expand and your all the small arteries, right, they will have punctures. They will crack. So even if you put your hand in hot water and recover, you're already having internal bleeding. All the nerves and all the small arteries got ruptured. So basically, your hand is dead. Then they'll remove the hand because you'll get gangrene. So be careful. If you're stuck in ice or something, you have to protect yourself. There's no way to treat it. You just remove the hand. Once you're frostbite, there's nothing you can do. The hand is gone. Do you ever think about it? All these great civilizations we talk about in ancient stories, right? Indus Valley, Mesopotamia, Inca civilization, all these things. Did you observe something in common? All these are near the equator. You have small civilizations, but not this big, mega civilizations near the poles. Simple reason, right? It is like if you see, right, country like India, Indus, right? It is hot. We are getting good rainfall, we are getting good tropics and everything. So once you get enough food, you have free time. Then when you have free time, what you do? You build armies, you build temples, you build monuments, you raise armies and you fight because you're bored. Kya karna hai? Right? But did you ever hear this thing? Eskimos who gone for a war. You'll never hear Eskimos going for a world war because it is so cold. Every day they have to survive, on food. They have to use most of their energy in surviving. They don't have time to build. So it works like that. Let's get this. So when you actually think all that, right, you can actually start connecting history. How do we do this? Well, I'll just give you one more example. Think about that. If you see the map, right, we have Europe, we have Russia. If you see Moscow and if you see France and everything, they're on the same latitude or longitude. But the temperature in Europe will be around 5 to 15 degrees. In Moscow, at the same time, temperature will be minus 15 to minus 20 degrees. How can the same latitude have two different temperatures? And if you think about it, if you see Europe, bloody, there are like 30 countries split into pieces. But Russia, there's one solid country. How is that? Why did that happen? Like, why Moscow is cold compared to the other cities which are on the same latitude? That's geography. Anyways, let's get this. And it's all physics, huh? We'll talk about that in heat transfer. How do we do this? Any answers? Let's get this. I'll give you a minute more. Let's see. Again, same story here. I hope you guys remember the bulk modulus. So bulk modulus ka formula is minus dp dv by v. So when you water freezes to ice, what remains same? So when this water becomes ice, the mass remains same. Mass of water is equal to mass of ice. So density of water, volume of water is density of ice, volume of ice. So from here we get volume of ice will be 1 by 0.9 volume of water, which is 10V by 9. That means the water V which was there, it would try to become 10V by 9. So if the shell was not there, the ice would have expanded to 10V by 9. This is the natural volume of the ice. So the ice would say, if the shell had not been there, I would have been 10V by 9. Are you clear with this? But because the shell did not expand, the final volume is V. I hope you're getting it. So in elasticity, the delta L, right, is always comparison from the natural volume and natural length, not from the initial length. Since shell did not expand, the final volume is still V only. So the change in volume will be V minus 10V by 9, which is minus V by 9. So the ice will think I got compressed by this much amount. I was supposed to be 10V by 9. For some reason, I'm V, so I got compressed by this much. Now apply the formula in the bulk modulus. So bulk modulus is minus dP. Now be careful, this V is the V natural, not the initial volume. That is the thing you have to be careful, that V is not the natural initial thing. So dV will be minus V by 9, and the V natural is 10V by 9. So you end up with dP is equal to B by 10. So the shell will experience a pressure of B by 10 because of the water becomes ice. Clear with this? Easy question, but yeah, concept, you should know that thing. And this bulk modulus of ice is around 10 power 9 or something. So that comes to around 10 power 8 Newton per meter square. That's roughly around 1,000 atmosphere pressures. That thing is sufficient to break pipes. Clear with this?
Sir, extra 10,000, right?
10 power 8, na? 10 power 5, 1,000, na?
Yeah.
Yeah. All clear with this? So these are some good questions. Like, if they're not difficult to solve, but idea are not difficult. Matlab, what is happening exactly? I hope you're getting that delta V in thermal expansion and delta V in elasticity are completely two different things. All clear with that? The next one is a pretty good advanced question. Again, it can be a standard result also, you can remember. Top view, there is no gravity. We have taken two rods. This is the interface. This rod Young's modulus is y1, area is a1, length is l1. This rod is y2, a2, and l2. Right? So find the distance moved by the interface when temperature changes by delta T. Now both the rods will try to expand and they'll push each other. Find the distance moved by the interface when temperature changes by delta T. Let's get this. Think. It's a good one. It's a really good one. If it's a simple mains question, I'll ask you this. When the temperature increases by delta T, which of the following options are right? Both the rods are elongated, both the rods are compressed. Rod 1 is elongated, rod 2 is compressed. Rod 1 is compressed, rod 2 is elongated. ऐसा चार options होगा.
So
You
do
can type
both
it,
of
Arya.
have same moment of same alpha?
अल्फा नहीं दिया क्या मैंने? सॉरी, माय मिस्टेक. अल्फा 1, अल्फा 2
ओके.
सब डिफरेंट है. आई थॉट यू आर टेलिंग द आंसर.
नहीं सर, इतनी जल्दी नहीं.
Type. Think. It's a good one, everyone. If this thing I would give you, though, I will give you advanced में single choice questions. Try. Just give it a try. Get some water and come. Hmm. Let's draw the picture. Huh? The picture is the main key in this thing. So listen, look at this picture carefully. The problem is the comparison is always with the natural length, not the initial length. So think of like this. Let's say there is no right side rod, okay? That second rod is missing. Then if you look at the left rod will say, okay, if the right rod was not there, I would have expanded till here. I would have expanded till somewhere here. And this length would be L1 alpha 1 delta T. Do you agree? If the right side rod was not there, I was free to expand. I would have expanded this much. Similarly, the left rod will say, if the right rod will say that the left rod was not there, I would also have expanded somewhere till here. And my additional length would have been L2 alpha 2 delta T. And let's say finally the interface has moved by a distance x. So this x is the distance moved by the interface. So now from here, when you drop a dotted line here, now tell me one thing. What will the left rod think I was supposed to be L1 plus alpha 1 delta T, but this is the extra compression. Do you agree? That green shaded part was the compression. And how much was that? So the compression in the first rod was L1 alpha 1 delta T minus X. Does that make sense? Are you getting the problem here? You're not supposed to take change in length from the initial length. You're supposed to take from, if there was no one stopping you, how much you would have got. And finally, how much did you get? Are you getting the difference? Again, if I take that Manika example, when I said your salary becomes 1,20,000, and if I give you only 1,05,000, it still pinches you. Making sense? You did increase, but it still pinches you because you're supposed to be 1.2, but someone is giving only 1.05. So the rod will say, I was supposed to be L1 alpha 1 delta T, but I could only expand by X. That means the additional compression that I got was this thing. Similarly, for this guy, would be even more bad. You will get all this thing. So this was X. So the second rod got compressed by L2 alpha 2 delta T plus X. So both the rods are compressed. So generally people think one has increased, one has decreased. It's not that way. Both are compressed because think of like this. Let's say if you and your friend are sitting in a place, right? And for some reason the place becomes very less, right? Do you think only one person feels compression? Even though you're strong and you're pushing the other person, won't you also feel little compressed? No matter how strong you are, when you push your friend also will push you back a bit. So even you will feel little, uneasiness. It will not be that comfortable. But is everyone clear with this E1 and E2? Please ask me. That should be the most important thing. That's why I said picture is more important. So if it's a mains level question, both are compressed. That was the answer. Most people think one is elongated and one is compressed. Because the problem was you're comparing from the natural length, initial length. Now, since the interface is at rest, there must be an equilibrium. The tension is same in both the rods. Then you're done. Once you got this, you're done. Then we know tension ka formula is YA by L into delta L. So we can apply this. This would be Y1, A1, E1. So this is your E. E1 will be L1 alpha 1 delta T minus X by L1. We are actually ignoring that L plus 1 plus alpha delta T in natural length. So this will be Y2, A2 by L2, L2 alpha delta T plus X. Solve this, you will get X is equal to Y1, A1 alpha 1, Y2, A2 alpha 2 delta T by Y1, A1 by L1 plus Y2, A2 by L2. There. Now the question comes, how do you know it is going to the right side? I don't know. So who decides that? The product. How do you know which rod is stronger? The product of YA alpha. So if YA alpha is greater than Y2, A2 alpha 2, this is alpha 2, then it will go to the right side. If it is lesser, you'll get a negative sign. Negative sign implies X didn't go to the right, it went to the left. Clear with this? So the sign will take care of itself. Please have a look at this. So the picture is the most important thing. So the comparison is always from how much you would have been and how much you are now. We really don't care what was your initial salary. It was always about how much did I promise you and how much did I give you end of the day. All clear with this? There. So these are like, this one, and this thing. So here there is one more thing. Since this stress is coming because of, elongation, this is also called as thermal stress. This is called as thermal stress. Because this is happening due to temperature. All clear with this one? Great. Let's see the next one. You have a 1 meter steel scale. Coefficient of linear expansion is alpha steel. Then you have a 1 meter wooden stick. Alpha wood is 0, so we're assuming wood will not expand. Then we also have 1 meter copper rod. Alpha copper is alpha C. When temperature is 30 degrees, when T is equal to 30 degrees, the scale shows 1 meter reading. So if when you use this scale to measure the wooden stick and the copper rod at 30 degrees, it shows 1 meter reading. The wooden stick and copper rod. Find the reading of the scale at 40 degrees. Now, if you increase the temperature to 40 degrees, the scale itself will expand. Matlab, your scale starts getting messed up. Copper rod also will expand. That is also messed up. So now, if you take this scale, which had an error, and if you try to measure, what will be the new reading? Find the reading of the scales at 40 degrees. So this is one of the problem we actually face. Did you ever notice this in the labs, especially when you go for electric lab or anything, you have ACs? Ever noticed it? Why do you think they have ACs? Is it for you to sit comfortably and think intelligently and do the work? Bullshit, it is not actually for you. It is for the equipment. Because the equipment, right, are designed, right, at some particular temperature. Mostly they take around room temperature 24 degrees. Most of the equipment is designed for Europe and all this stuff. So 24 degrees is the standard temperature. Now, if you bring that equipment from Europe and put it in India, and summer where temperature goes to 42, right, that instrument which is supposed to measure something, it will start measuring something else. So you need to maintain a proper temperature in the lab. So the ACs are there for the equipment to give you less errors, and it is not for your comfort. There. So yeah. So even when you go to IIT labs now, you'll have these big labs fully air conditioned. And that to Chennai mein. Summer mein socho, temperature bahar 45, 46 hai. Labs are one of the best place to stay in the afternoon. Hostels may don't have ACs. And I think last 3, 4 years, I'm noticing this. People are, skipping IITs and joining BITS just because hostels have more facilities in BITS. ये last year भी हुआ था. There was a kid, he was getting BITS Pilani Computer Science and BITS Goa Computer Science. He took BITS Goa Computer Science, even though Pilani was more reputed. And एक ही reason था, sir, Goa is close by now, I can come and go home whenever I want. And Pilani is like a desert, there's nothing to do, there's no life. I said, bloody, are you going there for a life or you're going there to learn something? I said, ठीक है. Now, at that point, you can't tell anything to the kid. I still found this reason decent. There is another idiot. He was getting IIT Kharagpur and IIT Delhi or Madras, कोई तो branch था. And they had a discussion. And he didn't take IIT Kharagpur because there is only one McDonald's or one KFC in entire Kharagpur. People had any shitty reason not to take. But telling you, right, these are good problems to have in life. Getting it? So you should have problems in life and they should be good problems in life. Should I go to IIT Bombay, IIT Madras? That should be the problem in life. Right? Should I go to Europe for vacation? Should I go to US for vacation? That's a good problem to have in life. Right? Am I buying a BMW or an Audi car? That's a good problem to have in life. So have good problems in life. Right? And to have good problems in life, you have to put a lot of work and be there. Because if you have bad problems in life, these are bad. Should I join Don Bosco Engineering College? Should I join KJ Somaiya? No, that's a very bad problem. So have good problems in life. Let's get this. So last year I brought a counselor after the advanced exam got over. So that guy knows everything about the colleges, and so they were talking, I was listening. So any shit discussion happens. Any nonsense, the kids ask questions, and that guy is also ready for anything to answer. Do they have washing machines? Can you go? How many washing machines are there? I said, oh, yeah, why the hell do you need all that stuff? I said, sir, we are sending kids, so we should know. I said, Pooch lo. I think last time we had that session somewhere in June. We started at 8 o'clock. It ended at 11:45. I said, okay. You guys will also have it next year. How to do this thing? So let me give you a general formula for this. Think about this. Let's say you and your sister are same height, right? And next day morning when you woke up, you suddenly became double the height. What will you think about your sister? Now, if you think you are normal, what will you think about your sister? You think your sister became half, isn't it? So if you become double, you think your sister became half. If you become triple, you think your sister became one third. What if you become triple and your sister becomes double? Now, because you became triple, you think your sister became one third, but because sister became double, she'll become into two. So you'll think she became two third, isn't it? Making sense? So when the scale increases, the length measurement goes down by a factor by which the scale increases. The factor. When you become double, the measurement becomes half. When you become triple, it will become one third. So it's a factor. So this is your general formula there. So the reading of the scale will be the length of the body at the new temperature. So when you increase the temperature, even the body temperature can change. By factor, the scale increases. So your steel scale, which was supposed to be 1 meter, now it became 1 into 1 plus alpha steel delta T. So by what factor did you increase? So the factor here is 1 plus alpha steel delta T. So it increased by this factor. So then you're done. So what is the reading of the wood? So if you use this scale to measure that wooden stick, now wood will not expand, so it will still remain 1 meter. And the factor is 1 plus alpha steel delta T. So this can be written as 1 plus alpha steel delta T whole power minus 1. We can use binomial approximation because alpha s delta t is very small. This will be 1 plus alpha s delta t. Numbers are given, you can substitute. I hope you remember binomial approximation. I showed you before. 1 plus x power whole n is 1 plus nx if x is much, much less than 2. Because alpha s delta t is small, you can always use that approximation. The answers will come like this. Be careful, huh? Even though this is also right, options may you'll always find the answer like this. They'll bring it to the numerator. What about the reading of the bronze? Bronze, copper rod. Now here the copper rod also will expand. So the copper rod length will become 1 plus alpha copper delta T by 1 plus alpha steel delta T. So when you take it up, this will become 1 plus alpha copper delta T, 1 plus alpha steel delta T whole power minus 1. This becomes 1 plus alpha copper delta T, 1 minus alpha steel delta T. This is 1 plus alpha copper minus alpha steel delta T minus alpha copper alpha steel delta T square. But again, alpha is very, very small and you're multiplying two alphas. So we neglect this. And your final answer is 1 plus alpha copper minus alpha steel delta T. So be careful. Final exam options will be like this only. They will not give this division wala. Even though it is right, the final options will look like this. Yeah, have a look at this. So whenever you change the temperature, your scales get messed up. All clear with this? Next one. So we have a pendulum here. Length is L. Alpha of the wire is 10 power minus 5 per Celsius. This is called a seconds pendulum. What is a seconds pendulum? The time period of one oscillation is 2 seconds. It's called seconds pendulum. So when this thing goes and comes back to the same position, it will take 2 seconds. So you have designed a clock in order to measure time using this pendulum. And you observe at 30 degrees, it gives you correct time. The pendulum is designed to give correct time at 30 degrees. Something happened, temperature outside increased. This is the formula for the time period. I'll use small t for symbol. We have done this in units and dimensions, 2 pi root over L by G. Hope you remember this formula. Errors में भी किया था. In case you don't remember, this is the formula for that. L is the length of the wire and G is the gravity. So the time period depends on length of the wire. Now, if you increase the temperature, length of the wire will increase. So the time period will get messed up. If the time period gets messed up, clock will start showing wrong time. So find the loss or gain of times. So how much time do you lose or gain per day when the temperature becomes 40 degrees? So if you design a clock with this, which shows correct time at 30 degrees, when the temperature becomes 40 degrees, do you lose time or do you gain time? What do you mean by lose or gain? For example, if the time is 1 hour, but the clock shows 1 hour 2 minutes, you gained 2 minutes time. Isn't it? Clock is running faster. If you get only 59 minutes, you are actually losing time. The clock is showing you less time. Making sense? Think of like this. Let's say you're going for some, go-karting race, and they tell you can ride the go-karting race for 1 hour. But if they let you race for 1 hour 5 minutes, did you gain time or lose time? You gained 5 minutes more, right? You're happy about it. But if they stop it at 55 minutes, you lost 5 minutes time. I hope you're getting the meaning of gaining and losing time. So how do we do this thing? Pretty standard model. In thermal expansion, right, there are 4 or 5 standard models. One was the scales. Second one is the time. And then we will see third is the cavities. Then we have something called bimetallic strip and the thermal stress. These are the 5 concepts you have. Let's see how will you handle this. Listen. So we know the time is 2 pi root over L by G. This is 2 pi L by G whole power of. What you can do, you can put log on both sides. We have actually done this in errors, power rule. But let me show it again. Put log on both sides. This will become log t. This will be log 2 pi. This will be half log L. And this will be minus half log Z. Now differentiate on both sides. Log ka differential will be 1 by t. So this will become dt by t. 2 pi is constant 0. This will be half dl by L. This will be minus dg by 2g. But we know gravity does not change with temperature. So this guy is 0. So you are left with dt is equal to t by 2 dl by L. So dt is the change in time period of the oscillation. Time is 2 seconds. That's your time period given in the question. This is 2. dl will be L alpha delta t by L. So this is alpha delta t. So we get dt will be 10 power minus 4 seconds per oscillation. That means every oscillation will increase by 10 power minus 4 seconds because the length increase, time will increase. That means the thing which is supposed to take 2 seconds, now it is taking 2 plus 10 power minus 4 seconds, or like 2.001 second. So each oscillation is taking more time. Tell me one thing, will you lose time or gain time? Again, think from this perspective. When you're taking the clock, yeah, I think, right, Samyak. Most of you did get it. You can do that, Arya. But again, why yoga? Alpha delta t small, to वापस approximation आ जाएगा. Same thing. Now understand here. So how does your clock designed? The clock is designed every time you complete one oscillation, the clock will count as 2 seconds. Agreed? But now you are taking 2.0001 second, but your clock still thinks it is 2 seconds, isn't it? Clock does not care about the actual time. Clock का एक ही है. One oscillation is 2 seconds. That is how you designed the whole system. But now that one oscillation is taking more time than 2 seconds. So what will your clock think? The clock will think 2.001 second is 2 seconds. That means every oscillation you're losing some time, isn't it? So pendulum takes more time for one oscillation. So clock loses 10 power minus 4 seconds per oscillation. And one oscillation is how much? 2 seconds. That is 10 power minus 4, 2 seconds per every 1 second. Now in a day, you have 86,400 seconds. For a day, we have 10 power minus 4 into 86,400 by 2. That comes to around 4.32 seconds per day. Right? So this is our time lost. So we lose this much time. So every day you lose 4.32 seconds per day. Clear with this? Kind of negligible because during nighttime temperature will drop and again the time period would increase. So you'll compensate the time there. So on an average, you will get a little error. Yeah, but even if you take a decade, you have an error of 40 seconds. So yeah, not a big deal. Clear with this? It's a good one. Now, if you're thinking where you have seen something like this, if you guys remember, there is a formula like this. If you have A is equal to P power X, Q power Y, R power Z, we have done this in power rule. dA by A is equal to X into dP by P, Y into dQ by Q, Z into dZ by Z. याद है power rule? We have seen this in errors. There it was always positive because errors are additive, but here we can take it like this. Clear with this? Take a break. Come back in 5 minutes. We'll continue from here. Any doubts on this? So come back in 5 minutes. Right. Okay. Uh, yeah. చేసుకోవచ్చు పర్లేదు ప్రాబ్లం లేదు అంటే బాగా నీ అకౌంట్ లో ట్రాన్స్ఫర్ పెట్టి ఎఫ్డి చేస్తారా చేసుకోవచ్చు అదేం ప్రాబ్లం లేదు కదా ఎందుకంటే అది అంటే ట్రాన్స్ఫర్ పెడుతున్నప్పుడు అది హస్బెండ్ ట్రాన్స్ఫర్ పెట్టారని చెప్పుకోవడమే ప్రాబ్లం ఉంది నీకు తర్వాత మన ఇన్కమ్ ట్యాక్స్ ఫైల్ చేసినప్పుడు కాల్ చేస్తాడు మేడం మీ అమౌంట్ ఎక్కడ నుంచి వచ్చింది అది కాబట్టి చెప్పలేదు మా హస్బెండ్ ట్రాన్స్ఫర్ ప్రాబ్లం ఉంది అది అది పెద్ద ప్రాబ్లం ఏమి ఉండదు కాకపోతే మరి దాని మీద వచ్చిన ఇంట్రెస్ట్ మీద మరి ట్యాక్స్ అయితే కట్టదు ఎంత వేద్దాం అది చేసుకోవచ్చండి ప్రాబ్లం అలా అనుకుంటే యూనిట్ పేరు మీద వేసుకోవచ్చు కదా. కాకపోతే యూనిట్ పేరు చేసిన బాగా అకౌంట్ లోనే పడుతుంది అది నీకు యాక్చువల్లీ పెద్ద తేడా ఏం పడదండి ట్యాక్స్ అయితే కట్టాల్సిందే అది సపోజ్ ఇప్పుడు నీ దాంట్లో నేను వేయట్లేదు అనుకో అప్పుడు నువ్వు వాళ్ళ ట్యాక్స్ ఎగ్జామ్షన్ ఇచ్చారు కదా 12 లక్షలు అనేసి అంత ఇష్యూ ఉండదని వేసుకోమని నీ దాంట్లో అంత బ్యాన్ అయితే ఉండదు ఇప్పుడు అంటే బాగా ఒక 1 రూపాయలు ఎంత ఇస్తే అంటే మామూలుగా ఇప్పుడు ఎంత ఆయన ఒక 6% 7% ఇస్తున్నాడు బాగా సపోజ్ ఒక 50 వేసాడు అనుకో 50 వేస్తే నీకు ఇంట్రెస్ట్ ఎంత అవుతుంది సంవత్సరానికి 3 లక్షలు 4 లక్షలు 3 లక్షల మీద 1% కాదు మామూలుగా అయితే అదే అదే అంట అమౌంట్ కొంచెం ఎక్కువ ఉంది అనుకో దాన్ని బట్టి నేను తగ్గిస్తాను కదా నీ దాంట్లో ఎక్కువ అయినప్పుడు బాగా ఒక 10 15 20 ఇస్తే పెద్ద ప్రాబ్లం నువ్వు ప్రాబ్లం లేదు వేసుకోలేదు వేసుకున్నాక ఎంత చేశాను ఒక మాట చెప్పేస్తే నేను దాన్ని బట్టి అడ్జస్ట్ చేస్తాను నీకు అప్పుడు ట్యాక్స్ కట్టాల్సిన పని ఉంటుంది అలా అడ్జస్ట్ చేస్తాను ఏం లేదు ఫోన్ ఉంటాను నెట్ ఉంటుంది అలాగే ఏంటండి రెగ్యులర్ ఇంటర్నెట్ ఉంటుంది వాట్సాప్ కాల్ ఎప్పుడు అవుతుంది రెగ్యులర్ కాల్ అవుతుంది యాక్చువల్లీ రెగ్యులర్ కాల్ కూడా అవుతుంది అది తీసుకున్నాను చెల్లి కావాలి కాకపోతే 4 గంటలు తేడా ఇప్పుడు 9:30 అంటే అక్కడ ఇప్పుడు 4 గంటలు అయింది నుంచి ఇంకేం ప్రాబ్లం లేదా ఖాళీ అక్కడ చేసేదే 2 గంటలు చూడలే ఇంకా ఇంట్లో ఉంటేనే పని ఎక్కువ అక్కడ ఉంటే ఇంకా ఖాళీ సమయం లేదు ఇంట్లో క్లాస్ అవుతుంది క్లాస్ అయ్యాక 12 గంటలు పని మీరు ఇప్పుడే 11:30 12 బయలుదేరి 4 గంటలు ఫ్లైట్ 4 గంటే అక్కడ 12 దిగుతాం 12 1 గంట దిగుతాం 1 గంట అంటే మీకు సాయంత్రం 5 అవుతుంది అది ఇష్యూ లేదండి దానికి దొరికితే వీడికి ఎందుకు పక్కన చలో కానీ ఏంటి పొద్దున్న ఎయిర్పోర్ట్కి వెళ్ళాక చేస్తాను చాలు Chal, hands on everyone. The next one is a bimetallic strip. So, like I said, there are five main concepts here. The first thing was the thermal stress. Second thing was the scales. Third was the time of a pendulum. Fourth one is a bimetallic strip. So, what is the bimetallic strip? So, when you take two different metals, are welded side by side, and when temperature changes, since you welded them, they have to be in contact. Other scans on, it bends. So, how is this working? See. So, let's say we take two strips here. Let's say one is copper and one is steel. Generally, copper expands more than the steel. Alpha copper is greater than alpha steel. Let the length of the rod be L. Let the thickness be D. Right? Now, what you did, you welded them. So, all these joints, right, you welded them. Now, if you increase the temperature, we know copper will try to expand more than iron. Now, see, it can't become like this. Copper can't become like this, and iron, this cannot happen because each point is welded. They're stuck to each other. Now, tell me, if they can't break out, and if the joints are really strong, and if the copper ka length has to be more than iron, what kind of shape do you think they'll take? If the copper has to be longer than this thing, so when temperature increases, copper ka length will be more than iron. Length of copper is greater than length of Fe, so it will bend like this. The copper will become the outside, iron will become the inner side. So the only way they can be together without breaking the points is by bending. Because when you bend, the outer layer will have a more length for the same angle. Right. So there will be actually a lot of shearing stress. We are ignoring all that. This is copper, and this would be your iron thing. So copper will be the outer layer, and the iron will be the concave layer. So copper will be convex. If the temperature decreases, this was a CT question. They have a copper and iron strip, temperature decreased. Then they give four pictures. Which of the following is the shape of this thing? So length of the copper will be less than length of iron. So remember, when you change the temperature, copper will change more. That is the meaning of alpha. Whether you increase or decrease, the change is more. So if you decrease the temperature, copper ka length will be less than this thing. So in this case, the shape will be like this. The overall length has decreased, but copper has compressed more. This is copper. This is your iron. Clear with this? So Now, if you are assuming L is much, much greater than D, we have few approximations. So let this thing be D and this thing radius will be R. And this angle will be theta. So here copper ka length will be L into 1 plus alpha copper delta T. Iron ka length will be L into 1 plus iron delta T. So from here we can see R plus D into theta will be L into 1 plus alpha copper T. Because the D is very, very small, I'm taking the outermost layer as the length of the copper. In reality, even the copper, every layer will have different length. So that will actually lead to shearing stress. We will not get into that. R into theta will be L into 1 plus alpha iron delta T. There, divide them, you will get R, and you'll get R, you'll get theta from here. You can calculate radius and theta. This is the concept of the bimetallic strip. Clear with this? So this thing is actually used, as a regulator in a way. Think of like this. Ever been to this sauna, the hot bath and everything? So I'll give you a simple setup. See, they used to use this once upon a time. Now they don't. So this is how the sauna works. So we have a circuit. So we have the hot bath there, right? And we have that entire setup here. So the setup goes like this. So we have the power supply here. And in the middle, you have your bimetallic strip. And let's say you have the heater connected somewhere here. So the heater is producing heat. So initially when the temperature is less, the bimetallic strip will be straight. So current will flow through the bimetallic strip and pass through the heater, you will get heat. As the room is getting heated up, when the temperature reaches 70 degrees, the bimetallic strip will start bending. Once the strip bends, the circuit, right, it becomes like this. Meaning the wire will get disconnected from the circuit. Current will stop flowing, heater will switch off. Right? Now the heater switches off because of radiation and everything, room ka temperature will start dropping 70, 69, 68, so on till 60 or 55 degrees. The moment you reach 60, the bimetallic strip will again become straight. Again, the circuit gets connected and heat continues to flow. So you can maintain a certain temperature range in the room, maybe 50 to 70 degrees ka beech mein. Without anyone coming and operating, it automatically goes on. They still use these things, in the fire alarms. So when your room mein the fire alarm, right, temperature rises, the bimetallic strip bends, and there is a small liquid there, it breaks, and then the fire alarm rings and all that thing. So the problem with this thing, right, because of that continuous bending straight, they actually develop something called elastic fatigue. At some point, it does not work that great. So it has a limit. Maybe it will work like 1,000, 2,000 times, and after that, it stops working properly. So nowadays, we don't use them anymore. Nowadays, we use more PCBs and circuits and stuff, semiconductor devices. Yeah, would the current increase? That is also there. So overall, we are taking the net temperature. So before all these things came, right, sensors and stuff, this is one of the way you can control. Clear with this? So you can actually use this as a circuit breaker. When the temperature of a region increases a certain level, it bends and the circuit becomes disconnected. This is your fourth concept. This is the question. This is the theory. So this is the fourth one, bimetallic strip. So thermal stress, time period of a pendulum, length of a scales, bimetallic strip. The fifth one is cavities. Again, this is a good theoretical thing. If a body has a cavity and if you increase the temperature, how does the cavity behave? So the gaps or the cavities behave as if they have same alpha as the surrounding material. What do you mean by that? So let me show you like this thing. Let's say we have a ring with a small gap. Now, when you see this thing, right, generally what people think, if you increase the temperature, the rod will expand and the gap will become smaller. That's the general feeling we get, right? Now, think of this way. Imagine you have a full ring, okay? You have a full ring. You take a marker and you paint this part with some red color. Now, if you heat the ring will become bigger. What do you think will happen to the red color marker? Won't that also become bigger? Is that making sense? So now if I remove the red color part, isn't the gap bigger? Now, what most people don't realize is this. I agree. When you expand, you'll go forward, but you're also forgetting you're also going outside. So whenever you have a gap like this, what remains constant is not the length, but the angle. What is the total angle in a small circle or a big circle? 360, right? It's always 360, doesn't matter. So if this angle was theta and this was radius r and this gap was d, and now if you increase the temperature, the gap will still have the same angle. That is a catch. Because the total angle is 360, that cannot change. The angle will remain same. The radius will be r into 1 plus alpha delta t. So the gap also will be d into 1 plus alpha delta t. So this is what I was saying. So all distances will increase by a factor of 1 plus alpha delta t. Whether you have a gap or no gap, it doesn't matter. So even the gaps and the cavities also become bigger when you increase the temperature. I'll give you one more example. This will be some theoretical questions. The most common misconception is they think gap becomes smaller. What you're forgetting, this thing is also pushing outside too. All distances increase by a factor of 1 plus alpha delta t, even if body has cavities. So this was the question in the exam. Huh? They said we have a rectangular sheet, and on the rectangular sheet there were two cavities. And they said there are 2 points here, A, B, C, and the question was this. When you increase the temperature, what happens to the distance between B and C? Define करेंगे आगे. What happens to the distance between B and C when you increase the temperature? When I say this, people remember this thing. So you said cavities will become bigger. So when the cavity becomes bigger, they should get closer. Now you have to be careful. Again, let's do it this way. Whenever you get confused about cavity, now this is how you do. First of all, forget about the cavity. Imagine you have a sheet. Okay? You have a full sheet. On this full sheet, take a marker and then you just put dotted circles. Imaginary dotted circles with a marker. Now increase the temperature. The sheet will become bigger. And this dotted circles also will become bigger. Now cut the sheet and remove this thing. What do you think happened? The cavities became bigger. The distance also between them became bigger, na? Is that making sense? When you increase the temperature, the metal between this also will expand. So that was the meaning of the statement. All distances increase by a factor of 1 plus alpha delta t. So it doesn't matter when, what distances you take. AB ka distance, AC ka distance, BC ka distance, BD ka distance, all distances will increase. There, this was a question in the exam. So the sheet becomes bigger, the cavities become bigger, so everything increases. AB, BC, CD. Increase by a factor of 1 plus alpha delta T. Yeah, right here. All favor this? That's about a linear expansion. Now, if lengths change, you'll have something called aerial expansion. This is mostly theoretical. So what is aerial expansion? Let's say we have a sheet where this is L1, alpha 1, L alpha 1, and this is B alpha 2. See, there is no guarantee materials will expand same in every direction. Some materials are similar in every direction. For example, take graphite. When you take graphite, the graphite structure in a plane and the graphite structure in the other things is different, isn't it? If you look at graphite structure, there is no bonding, proper bonding between layer and layer. That's why when you push a graphite, right, it easily slides. That's why graphite is used as a lubricant. Graphite layers can slide. So when you're writing with a pencil, that's what you're doing basically. The pencil graphite layer is getting stuck on the paper, and the next layer is coming. So there's no guarantee it will be same in all directions. So this kind of materials are called anisotropic materials. Isotropic meaning uniform, anisotropic. Material has different alpha along different directions. Then this becomes L into 1 plus alpha 1 delta T. This will become B into 1 plus alpha 2 delta T. So the change in area will be the final area minus initial area, which would be L into B, 1 plus alpha 1 delta T, 1 plus alpha 2 delta T minus LB. LB will cancel. You'll end up with LB, which is your initial area, 1 plus alpha 1 plus alpha 2 delta T plus alpha 1 alpha 2 delta T square. We know alpha is very small. We neglect the higher terms. So there. So we get delta A is equal to, this 1 does not come. A initial alpha 1 plus alpha 2 delta T. We write this thing as A initial into beta delta T. So beta is alpha 1 plus alpha 2. This is called coefficient of aerial expansion. Just like linear expansion, this is an aerial expansion. So you can write beta as 1 by area dA by dt. If the material is uniform, if alpha 1 is equal to alpha 2, then your beta becomes 2 alpha. That's mostly a CET level type question. Please have a look at this.
Sir, what if like there are we can't define the materials expansion in two alphas, then what will we do?
वो होता है ग्लास के साथ होता है ऐसा. Glass has different alpha at different point. That means your alpha is changing with position, na? Then it's become variable actually. Then beta भी x के साथ change हो जाता रहेगा. Then it becomes like this question which we did. Remember case 2? We're talking about this case. Generally happens with glass. Glass is not uniform. When it suddenly cools down, right, the structure has a lot of internal stress and it's a little messed up. Clear with this? This is called aerial expansion. Again, not really something new. It is just based on alpha. Then we also have volume expansion. We use gamma. This is important. Beta is really not that important, but gamma is important because we define this for liquids and gases. Because for gases and liquids, alpha does not make sense. There's nothing called linear expansion of a gas, linear expansion of a liquid. But gases and liquids have volume. So if you take a cuboid, let's say L, alpha 1, B, alpha 2, height, alpha 3, you know those things, same standard story. Delta V will be LVH, 1 plus alpha 1 delta T, 1 plus alpha 2 delta T, 1 plus alpha 3 delta T minus LBH. So we get delta V is equal to V into alpha 1 plus alpha 2 plus alpha 3 into delta T. We neglect all the higher powers. So we can get delta V is equal to V gamma delta T. So gamma is 1 by V dV by dt. That's important result. Huh? And gamma is alpha 1 plus alpha 2 plus alpha 3. If alpha 1 is equal to alpha 2 is equal to alpha 3, then gamma is equal to 3 alpha. This question has come multiple times. Huh? Let me show you the question. You guys can try this. They said a gas V is equal to kT square. K is equal to constant. So a gas has a process which is V is equal to kT square. And the question is find gamma. Can you find it? That's a PYQ. A gas undergoes a process where V is the volume, T is the temperature. V is equal to kT square, K is constant. Find the coefficient of volume expansion of this gas. Bas, that was a question. Let's see. So direct formula substitution, there's nothing there, differentiate. So gamma is 1 by V dV by dt. So 1 by V is 1 by kT square and dV by dt is 2 kT. 2 by T. That's the answer. Options were 1 by T, 2 by T, 3 by T, 4 by T. ऐसा था चार options. So they would ask questions on this. So be careful with this. Now for liquids and gases, alpha and beta don't make any sense. So only gamma is defined. That's why gamma is important. Yeah, all of you 2 by T got it. Perfect. Clear with this? This is your volume expansion. Now, when you increase the temperature, the liquids will expand, and the liquids expand, the density changes. So this leads to variation of density. We know density rho is nothing but mass by volume, and mass does not change with temperature. So the new density will be that same old mass by the old volume into 1 plus gamma delta T. Gamma is your coefficient of volume expansion. So the formula becomes rho old by 1 plus gamma delta T. There. So whenever you heat up a liquid, the new density will be the old density by 1 plus gamma delta T. Gamma is your coefficient of volume expansion. So generally, whenever you increase the temperature, liquid's density would decrease. Water is an exception. Water does something weird. That's what you must have studied in chemistry as anomalous expansion. The thing normally, right, if you see any solid, right, and if you take any substance, the solid form has more density than the liquid form. Water is an exception. These things will start forming their hexagonal structures, and because of that, you get air spaces in middle. And because of that air spaces, right, the whole density actually drops. And that is actually a savior. Huh? If that was not the case, we wouldn't have existed. Think about this. Earth, right? Every time there's an ice age, the entire Earth freezes for like a few thousand years. Did you ever see this thing? No matter how cold it gets, oceans don't freeze completely. It takes time. It takes a lot of time. Simple reason. Every time it becomes cold, it'll form ice. Getting it? Now, because imagine if ice was denser. If ice was denser, the moment it forms ice, it will sink. That means the bottom of the ocean should have been frozen, no? So as the ice is continuously forming, ice will keep sinking. The entire ocean would have been frozen. But you will notice, even if you go into Marina Trench, right, the temperature is, you will never find ice at the bottom of the ocean. Even if you go to, Antarctica, right, and when you go deep down, ice is there on the top. So what happens whenever ice forms, because it is less denser, it will float. And ice is actually a bad conductor. Ice does not let heat flow through it. Don't get confused. If you touch the ice, you will, it is bad. But if you put an ice slab and if you put a plastic sheet or something, and if you sit on top of it, it actually acts like a good insulator. Did you ever think about this? Eskimos build their house with ice, right? Igloos. Because ice is actually a bad conductor. So what they do, they make it with ice, and inside, right, they take this animal ka hides, the deer or whatever reindeer ka hides, and they actually put them like a insulation there. So let's say if you're going for some ski resort and there's a big avalanche and you got stuck in the ice, the best thing to do, make a hole in the ice, right? Make some empty space. You can just sit inside, put your coat or something there, and you can just sit inside. You'll actually be more warm rather than just jumping outside and running around. Waiting for rescue is a better idea there. Because the ice, right, is like a fluffy, right? There's a lot of air in between, and air is a bad insulator. So this anomalous expansion, if you look at density versus temperature, so this would be your density of ice around 0.9. You reach a peak value somewhere at 4 degrees. And then the density drops a bit again. So at 4 degrees, water has the maximum density. That means the moment, let's say it is summer, temperature is 30 degrees, winter is approaching, temperature goes to 20, temperature goes to 10 degrees, 7 degrees. The moment it hits 4 degrees, water becomes the densest. Basically, it starts sinking before that only. That means at the bottom of the ocean, you will find water which is at 4 degrees. Isn't it? Because that's the densest water. The water at the bottom of the oceans is 4 degrees, and 4 degrees ice does not form. Because for ice to form, you need to go sub-zero. You can say like that. In a particular range, gamma is negative for ice, actually. That is the reason fish don't freeze at the bottom. And when there is a winter, right? Normally, what happens? The upper layer of the lake or this thing gets frozen. The fish at the bottom are still happy. They're just moving around normally. And when the winter comes, ice melts, and again things go back to normal. So that's your anomalous expansion there. So 4 degrees water is the maximum density. Clear with this? Ice forms when you go sub-zero. God, 4 degrees you don't get ice. When temperature goes to 0 degrees, then ice starts forming. Na? As long as you're above zero, it goes. Marina Trench mein temperature is not zero, it is 4. Who maintains 4? Earth ka core temperature. There is a heat flowing from Earth ka core to the crust. Clear with this question? 4 degrees. No, there was a question on this also in the exam. The question was this. You have a glass of 4-degree water. Glass completely filled with 4-degree water. Now, if the temperature increases or decreases, in which case does the water overflow? Let's say temperature become 5 degrees or 3 degrees. If temperature increases or decreases, in which case water overflows. Right, Arya. What do you guys think? Nishri Hari. Yeah, right, Samyak. Again, just now think about this. At 4 degrees, water has maximum density. That means it has minimum volume. Whether you increase the temperature or decrease the temperature, in both the cases, density will decrease. That means volume will increase, so it will overflow in both the cases. Clear with this? Easy, simple theoretical question. Let's see one good question on this.
So, sir, does any other material show this property?
There might be something. I don't know. Could be. Hoga, you need to Google it out. So we have a liquid here. Density of the liquid is rho. Gamma is the coefficient of volume expansion of the liquid. In this, you kept a block. Cube of Seidel. Rho b is the density of the block. Alpha is the coefficient of linear expansion of the block. You know this thing from fluid mechanics, isn't it? So x is the depth inside the liquid. Now, if you increase the temperature, density of the liquid will change. The size of the block also will change. Right? So everything gets messed up. Okay, we have silica, germanium, beryllium. Great. So we have other liquids also. So find the new x when temperature changes by delta T. The density of the liquid is block is less than density of the liquid. So it is floating. So initially the block is floating with a depth x. Now when you increase the temperature, the block size length will change because linear expansion. The liquid density also will change. So x also will change. Find x. Let's get this. Fluid mechanics, thermal expansion, everyone. And they can ask a question like this: find the relation between gamma and alpha if x does not change. Other scams on, not sure why you guys keep switching off the camps as if you have something really important to do. Shaunak, Shreyansh, you guys are not there in the class only.
सर वो तीनों अल्फाज को सेम मानना है ना?
या कुछ नहीं दिया तो सेम ही है. 1 plus gamma delta t by 1 plus gamma p delta t. Where is gamma? दो gamma कहाँ से आए आयुष्मान? I hope the question was clear, everyone. No, Ishpan, that is wrong. You fell into a classic trap. How do you approach this? Let's see. Near area. You also fell into the trap. Let's draw the picture. You will understand. See, initially, when the temperature was normal, when the block was immersed here, what are the forces acting on this? We have the bind force, which is density of the liquid, x into L square into G. And your weight was mg, right? So yeah, so that is rho L x into L square G is equal to mg. This was the initial situation, and right from here you got x. Mg will be how much? That will be rho b L cube G. So we get x is equal to rho b by rho L into L. This was the standard result. Now when the temperature increases, your block now has become bigger. It became L into 1 plus alpha delta T. The size has increased. Now let's say it is into the liquid up to Y. This is L into 1 plus alpha delta T. This is also L into 1 plus alpha delta T. Now you have a new bind force, Fp, which is the density of the liquid, and this is your mg. Now remember, mg does not change because you increase the temperature, so mg will remain same. Still it is an equilibrium. So the new bind force, Fb new, will be the new density of the liquid into the volume, which is Y into L square 1 plus alpha delta T square into G. That's your new bind force. Clear with this? And remember, when you increase the temperature, mass does not change. M is constant with temperature. Right? So this must be equal to your mg. What is the density of the new liquid? The old density rho L by 1 plus gamma delta T. This will be Y L square. You can use binomial approximation 1 plus 2 alpha delta T that alpha squared delta T squared term will be 0. M will be rho B into L cube because that was the initial mass. From here, you'll get y is equal to rho B into L by rho liquid 1 plus gamma delta T by 1 plus 2 alpha delta T, which is nothing but x into 1 plus gamma delta T by 1 plus 2 alpha delta T. It's 2 alpha there. It's not 3 alpha. Meaning, think about this logically. When you increase the temperature, the base area is increasing, right? Why does it matter how much block is outside the water? The base area is increasing. Now here, if I use binomial approximation, because gamma alpha is small, you get y is equal to x into 1 plus gamma minus 2 alpha delta T. So if gamma is greater than 2 alpha, the body will sink more. If gamma is less than 2 alpha, body will come out a bit. If gamma is equal to 2 alpha, x will not change. No matter how much you increase the temperature or decrease the temperature, x will remain same if gamma is equal to 2 alpha. Right, Samyak?
Sir,
Hmm.
sir, for no change in X, what if we like equate their specific gravities?
Which specific gravities?
Like
How can
we
you
take
equate
the
specific
ratio.
gravities? You have to equate the forces. Buoyant force is equal to mg. That is the equality, right? How can you equate the densities? Where if the densities are equal, it will completely sink, right? Why it will float outside a bit?
No, sir, not like that. Ki, ratio of the initial.
Why ratio? It is density into volume is constant, not densities. Na? Rho 1
No,
v1 is
sir, I
equal to
was
rho
like
2
thinking
v2.
ki if specific density for a block is half, then half of its thing will be in water.
Not necessary. Na? वो starting है. But when you expand it, is there any guarantee density also will change in the same way for both of them? You are
Yeah, so if
assuming.
we want no change in X, तो वो time पे भी half चाहिए ना हमें.
देख लो मतलब इतना मेहनत क्यों करना है? Keep it
क्वेश्चन
simple
3
ना.
आया था तो मे बी इट्स रॉन्ग. सम
नहीं, that is
फ्लॉ इन द
wrong. नहीं
लॉजिक.
वो उसमें see what you're doing was this. Rho 1 v1 is rho 2 v2. End of the day you're doing this, isn't it? v1 is the
या
volume
काइंड ऑफ
displaced. अभी
यस.
हाँ, अभी राइट साइड टर्म तो चेंज नहीं हो रहा है ना. This is constant. All clear with this? There, you get a question on this thing in fluid mechanics. So that's a little bit on this. So we can see now expansion in fluids. So we have few more questions on this before wrapping up the chapter, right? So we will do that in the next class. And like I told you, right, next week there'll be no class. So we are on a break next week. So the next